We're looking at homework from section 5.2. This is question number 10. Use the normal distribution of SAT critical reading scores for which the mean is 509 and the standard deviation is 120. Assume the variable x is normally distributed. What percent of the SAT verbal scores are less than 650? And if 1,000 SAT verbal scores are randomly selected, about how many would you expect to be greater than 575? So we'll start with part A. We need the positive side of the standard normal distribution table because the x value we're looking for, 650, is larger than the mean. We'll find the z-score for x equals 650, which is 650 minus 509 over 120. That's 141 over 120, which is 1.18. When we look up 1.18 on the standard normal distribution table, we find a table value of 0.8810. Because we're looking for the probability that the scores are less than 650, this table value is going to be the area. So that is 0.8810. Converted to a percent, that means that approximately 88.10% of the SAT verbal scores are less than 650. And that's your answer to part A. In part B, we need to do a similar thing, but then we'll have to do some multiplication at the end. We're looking for the probability that the SAT verbal scores would be greater than 575, so we need that z-score for x equals 575. Z equals 575 minus 509 over 120, which is going to be 66 over 120, which is 0.55. That has a table value of 0.7088. So now what we have to do is we have to do the probability that x is greater than 575 is 1 minus this table value because greater than represents area to the right. So 1 minus 0.7088 is 0.2912. We're going to take that 0.2912 value, and to find out how many actual exams would have that score, we will multiply this 0.2912 times the 1,000 individuals that took the test. That leads us to a value of 291.2. So we would expect that approximately 291 of the SAT verbal scores would be greater than 575. We wanted to round to the nearest whole number here. And that's your answer to part B, and those are your answers.